Hello, everyone. Welcome to this week's episode of Nuts About Thrust. Today we have Josh here who's going to talk to us about kind of his career in aviation maintenance and how things have led up. And I'll just turn it right over to you, Josh. If you could introduce yourself and tell us what it is that you do.
Yeah, Josh Keithan. I'm currently the director of customer support for an aviation tech manufacturer. We build a vibration monitoring system for helicopters.
Why is that important?
Just like any other kind of machine, helicopters have the potential to have failures that are unscheduled, things that go wrong with equipment that aren't based on design. Things that even if you maintain a system perfectly, there's always a potential for failure. And so this kind of system can detect those failures before they become big enough problem to cause aircraft to go down either for unscheduled maintenance or worst case, a catastrophic accident. So
Okay.
it's an additional safety feature plus the potential to return investment for operational availability for customers.
Okay. So is it monitoring vibrations, or how is it collecting data, and where's that data stored?
Yeah, so we have sensors distributed around the airframe in the relevant areas where we need to get the vibration from, attached to gearboxes, near drive shafts, near the rotor systems. But then we're also interfaced with the aircraft instrument systems. So we're getting, all parameter data for airspeed, engine temperatures, pressures, torques, things like that. We can describe the aircraft's operating condition. And that helps us both dictate when to take vibration data when it's appropriate. Obviously, depending on how you operate the aircraft, those vibration levels can change. So we want a repeatable measurement so that we can determine over time when things start to trend, whether it's because of a mechanical effect, because of it's no longer normal. And then we're also doing things like providing solutions for tuning aircraft rotors. So helicopters have rotor systems that have to be balanced manually. All of the components of the system they're not all identical in weight and shape. So there has to be some in-service tuning, and we provide a tool for mechanics to use to do that.
Okay, and
Cool.
a quick question, if you don't mind. And if I'm just understanding, and I'm not a pilot or a technician, but if I'm understanding the concept correctly, different types of vibration readouts will indicate certain things going wrong,
Right.
And that's just kind of like an algorithmic sort of process, right?
Exactly.
Yeah. Okay. Well, that's interesting. Yeah, it's cool.
Yeah.
Yeah.
So a gear makes a different vibration than bearings, and all of that has a different type of signature that we look for, and it can tell us specific things about those components. And to be clear, traditionally this kind of thing isn't done, right?
Right.
We call it HUMS, Health and Usage Monitoring Systems.
That's good.
And it's only traditionally been available on large helicopters. It's been very expensive and very heavy. But we moved into the new age. We're making modern technology fit an untapped market, which is all the light and medium aircraft now. It's more affordable, it's smaller, it's more compact, it's more reliable, all those things that need to happen to bring it into the new age. And our founders, came up with the technology and all the stuff to make it happen, and that's what we're doing.
And that's more useful for the people who own those aircrafts too, right? Like you said, being more flight ready and things like that. So it's
Operational readiness,
Yeah.
all of those things.
Okay. I'm curious about how you got there, what you did before that.
Yeah, I mean, I'd say my story is pretty diverse. I've been pretty fortunate. I started out like many do, right out of high school, kind of trying to figure out what I wanted to do. I was interested in cars like a lot of us are, and I was kind of looking down that road. I had considered the military, but I didn't think I wanted to invest that kind of time. I needed to go out and start making some money, to be honest.
Yeah.
So I started looking at options, and someone had mentioned aviation, and it sparked my interest. I looked around. There was an aviation school in Houston near where I lived. Signed up, went to school. I graduated kind of pretty much in the worst time that a technician could have graduated in the last decade, which is right after 9/11. Aviation industry was suffering, economy was suffering, but it was kind of an interesting story. I got out of school. The school tries to help you find a job, and they were unsuccessful. Northwest Airlines had closed down, and none of the airlines were hiring at that time. So basically, I was just home trying to figure things out, and I picked up a phone book. It's these old things that had things written in it, phone number.
Yeah.
Anyway, and I looked at the local airfield, and a helicopter company was based out of there in Galveston, Texas. And I literally just called the phone number and randomly got the hiring manager, who was never really at that location. He just happened to be stopping by. And anyway, he hired me on my birthday like the month later.
That's freaking awesome.
And so Petroleum Helicopters Incorporated, PHI, was the name of the company I started with. Very fortunate to be working with and be trained by a lot of like Vietnam era guys. I think I might have been the youngest guy that PHI had hired in the last 5 years. So a lot of guys took me under their wing. Very fortunate to be a part of that. Learned a lot really fast. We were at a very busy helicopter base in Galveston. We had something like 25 helicopters operating, all different kinds, all different types and manufacturers. So I got to touch a lot of stuff, which is not very common these days. So I learned a lot.
You got to be hands-on. That's what you're saying.
Yeah.
Oh, yeah.
With lots of different manufacturers.
Okay, yeah.
Right. Yep.
Oh, because usually you specialize in a manufacturer because they have their own.
It's rare for a company to own a lot of different aircraft types, helicopter types, because for every type you have, you got to keep a spare warehouse full of parts for that aircraft. It makes more sense economically to fly as few models of aircraft as possible. But it was a time when oil and gas transport offshore was a lot more. It was a lot busier these days. Especially shallow water stuff offshore is not really around anymore. So there's less and less aircraft that are doing that work. At the time that I hired on with them, it was still very, very busy. So yeah, I learned a lot in a short period of time. And PHI also had an air medical division, transferred to that side of the business, worked there for several years. Got to learn, it's a whole different business model. The helicopters are out there competing basically for patients.
Oh, okay.
The first one to the scene gets the patient. They take him to the hospital.
Okay.
Yeah, 24 hours a day, 7 days a week kind of job. But you have it. I was pretty fortunate. We had a back-to-back, so we would go 7 days on, 7 days off.
Okay.
Did you do that when you were working oil and gas as well?
Yeah. So in the oil and gas industry, and a lot of other industries are following suit, the schedule is often a 1-to-1. So it's either going to be a week on, week off, 2 weeks on, 2 weeks off, 28 days on, 28 days off.
Was that difficult to adjust to? I mean, you got into that, but was that difficult for you to adjust to coming from not doing that?
Yeah, I mean, it was different. I mean, but most people fall in love with that schedule and never want to leave it. That's because you get 2 weeks off every month.
Yeah.
You're working 12 hours a day when you work your 7 days on. So you work 80 hours in 7 days, right?
Yeah.
I would say it's a great schedule.
Yeah.
It's one of the, if you're looking to get into aviation, and helicopter aviation especially, that's one of the biggest benefits out there is the great work schedule that they have.
Yeah, no, that makes sense. And then what did you do after you moved on from that part of the business?
So I got into the aeromedical side and still line mechanic, turning wrenches on a helicopter. It was interesting for a while, the on-demand nature of it, the constant, the aircraft has to be ready 24 hours a day. So when you do maintenance, it's got to be efficient. And I liked that part of it. I got to man my own parts warehouse. But eventually, you get bored. I'd learned the aircraft inside and out. And I really wasn't learning anything new. And I decided it was time to start looking, what else was out there. And specifically, I was looking at international work. Applied for a job with a company called Heli Malongo in West Africa. Doing oil and gas transport, similar to what I was doing before with PHI, but they were doing it on the African coast there. Chevron had an operation there that we were supporting. So moved over there.
That's cool.
Started out in, they hired me as a technician, but as it was being set up, they determined that they needed a quality assurance team. And so quality assurance is kind of a special position in the maintenance structure. And their job is to make sure that all of the documentation, the legal requirements of the maintenance are being complied with. Managing the requirements for all the components, their in-service times, their all of that stuff, making sure everything is by the book, basically.
Yeah.
And so I had not done that job. I had known about that type of job, but I'd never done it before. So got kind of thrown into the fire with it.
Yeah, sounds like.
Anyway,
that'd be kind of a pivotal time in your career, though, right? I mean, it's a big change. It sounds
huge.
like, kind of.
Yeah, I mean, I learned more about the underlying structure of aviation and all the regulatory side than I would have otherwise. But that job is within reach of any technician, right? Most quality assurance guys are technicians, ex-technicians, if not all of them. So yeah, I got into that. it just keeps going. I mean,
Yeah.
I moved from quality assurance into maintenance training and doing maintenance instruction, a lot like you were doing in your previous role. And then from then on, I went into the HUMS field. So we had an aircraft accident in Angola. An engine literally exploded, and luckily everybody was safe, and the aircraft was safe, but it damaged. It was a twin engine aircraft, damaged both engines, damaged the airframe. I'm not sure if it was ever recovered.
Mm-hmm.
The system had a vibration monitoring system on board, but there was no program or any process for managing the data and what to do with it.
Mm.
So, I got voluntold to, investigate this and see what I could do. And I took it up. I was very interested. Obviously, I'm the kind of guy that's always interested in the next thing.
Mm.
So dove in and ignorant to a lot of it, but learned quickly. There's a lot of knowledge out there to be had from people that done this in the past. Learned all about the vibration analysis stuff, and then we were able to determine what had caused that accident. We went and looked for the same behavior in other aircraft and ended up finding 4 other aircraft that had the same condition and multiple other engines. Took those out of service before they caused any harm. Sent them through overhaul, verified that sure enough there was a problem, got them fixed and back in service. So that basically made me fall in love with the vibration analysis.
Yeah, I can
stuff.
see that. Yeah.
It's like, man, that was a contribution, right? We actually did something here.
One of the questions I get all the time is, hey, what kind of job can I have as an A&P? Right? And I'm like, the world is your oyster, right? Like there's so many different things you can do as an A&P. And I think, Josh, you have a really cool job today that you would not have if you hadn't gone to A&P school, we'll say 10 years ago or so.
Yeah, just 10.
Yeah.
GPMS International Inc.'s a company I work for. Look us up online. Lots of good data on the website.
Yeah, and like you said, as he collects more data, it's like any technology company, right? The more information I have about the vibrations that are coming off of this particular type of gearbox installed in this particular type of aircraft operated in this particular type of environment, then they can trend all of those and they can start to predict failures before they ever happen.
Yeah.
Right?
So it's a concept that many people probably don't understand that aren't in aviation, but an aircraft is designed to with a certain design safety level, right?
Mm-hmm.
And the reason we do maintenance is because using that machine degrades its safety based on the original design. The gear's got to be this shape, it's got to be this lubricated, it's got to be all these things, right?
Mm-hmm.
Maintenance is the restoring of that machine to its design safety level.
Mm-hmm.
The problem is that long periods of time can go between when we're able to look at things, right? So if we imagine a transmission in your car, it would be very hard to look inside that, right? A main gearbox on a helicopter is the same kind of thing. All these gears and bearings turning in there, there's really not any way to see that stuff.
Mm-hmm.
And so we use these kind of secondary and tertiary indications of problems. Simply, they have a magnetic plug at the bottom, like a lot of cars do in their oil tank.
Mm-hmm.
And when metal starts coming off the internal components, it might trigger a light.
Mm-hmm.
But by that time, the safety level of the machine is destroyed.
Right.
So now it must be removed and overhauled because regulations require it. It's not like a car. You can't just keep driving it till it blows up.
Just kind of
tuck
over to the side.
So what we're doing is, this kind of stuff looks inside the gearbox with vibration. It's like an X-ray, but we're using vibration signals instead of light.
So
That
when
makes
you
sense.
have big spikes and vibration changes, that's could be an indicator.
Right.
Somewhere,
And when these systems are new, you don't really know, but you're like, hey, we've had a bunch of increased vibrations. We should take a look at this. And maybe it's nothing. You go, okay, then you program that in as, hey, there's some anomalies in the readings.
Yep.
Or like, hey, I can tell that the number 2 bearing on that engine is, degrading.
Yeah, I think the golden egg from this whole thing is probably the biggest area of untapped value left in aviation is the TBO, the time between overhauls of these components.
Mm-hmm.
So a manufacturer decides based on a lot of things, hey, this gearbox is going to have a 5,000 hour overhaul. 5,000 hours, you got to take it out, you got to completely disassemble it, inspect everything, put it back together, replace parts, put it back in service. But most of the time, probably they could go another 5,000 or even another 5,000. But because of the safety margin, you have to take them off.
Yeah.
But if we can see inside, why wouldn't we let it go further? Right. And so it's very, very expensive for these companies. I mean, a majority of their maintenance cost is overhaul costs from engines, gearboxes, all these things. And so the idea is that hopefully, eventually, we have some regulatory mechanism to extend the life of these components using this kind of data. And it's been done a few times, and in certain areas under the EASA European regulations, it can be done. In the U.S., there's not a ready mechanism for it. It has to be part of the original type design of the aircraft, built in. And there's not very many new aircraft being built these days. But I think in the future, I mean,
no, they're going to get there.
Yeah.
I mean,
the economy is always going to find a way to tap into value, right?
Yeah.
Right.
and the regulators are going to push back, but the industry is struggling right now.
Well, yeah, and if you can find money for the industry in places like doubling the time it would between overhauls, and then I'm
There's
sure that
billions of dollars on the table.
Yeah,
yeah.
exactly.
If you think about like we both have a helicopter background. We think about a Bell 412 main transmission has a 5,000 hour overhaul. That overhaul is going to take about 240 man hours. So just to take the gearbox apart, put it back together, 240 hours.
That's if nothing goes wrong.
No, and all the parts are on condition. So they're most of the time they're going to go back in. A lot of times people replace all the bearings just because it's only about $7,000 for a new set of bearings.
Yeah, that's cheap for helicopter parts.
And then but still 240 man hours at $150 an hour, like that is an expensive,
very expensive thing.
proposition, right?
Yeah.
Plus the downtime of the aircraft itself. The aircraft is, its job is to be out, available.
If it's on the ground, it's losing money.
Yeah.
I'm curious about if somebody watches this and they watch that first half of the episode and they say, okay, I hear all that stuff. Where should I start?
Yeah.
What kind of mindset do you say someone should have going into this? Because like you said, you got to get your hands on a lot of different manufacturers. I mean, not everyone's going to get that opportunity. I'm curious if in hindsight you have any tips for new AMPs.
Yeah. I mean, well, first of all, when any of us come into the industry, there's going to be a time before we're really delivering value for that company, right? You've got to be trained by the company after your AMP school. There's a lot of work to do still, but I think but that's going to continue your whole career. We never stop learning as technicians.
Yeah.
And if we stop working on something for 6 months and go back to it, we're going to have to relearn it because there's one aircraft might have 20 different systems we have to understand. And so it's always there. The documentation is always there to guide us. That's one thing. It's not what's in your mind that matters. It's your character, your personality. I'd say the most valuable attribute in any technician is resourcefulness.
We've heard that.
Know that the information's there and have the motivation to go seek it out. And always be asking why. That was me. And I think it got me in trouble sometimes. I always wanted to know why. Why are we doing it that way? Why are we doing it this way? But that led to a deeper understanding of the reasons we were doing things, why the system is built like it is. I made smarter decisions as a technician because of it. Obviously, they've got to teach you how to turn the wrench and do the safety wire and what you got to take off when and all of that. But if you as an individual can pursue that knowledge and just always be curious, always be asking why, that's going to get you a long way. Yeah. And volunteering to do the stuff that nobody wants to do.
Yeah, right.
I'd show up at work and they'd say, okay, what do you want to work on? And I said, whatever you guys don't want to work on. I want to do the hard stuff. That was, I think, a reason a lot of guys took me under the wing is because I was eager to learn through experience. I wanted to learn by putting my hands on it.
If you're the guy that's always volunteering and learning and trying to move forward, when they're like, hey, we need somebody to go, to go look at this aircraft in Paris during the Olympics.
Right.
They're not going to pick the guy that was hiding in the corner, right?
Mm-hmm.
And there's plenty of those opportunities.
Sure.
I've never been to Paris during the Olympics, but I've been, me and Josh have worked all over, right? And it's because of that type of, mentality.
Yeah. It's a proactivity. I like that. So far we have had a great conversation about, first of all, the company you're working for. It's a GPMS, right?
GPMS International.
International, gotcha. So we've had a great conversation getting to know Josh and what you do for a living. We've also got to kind of understand how your company plays a role in the industry, and I think that was very interesting to me. I like to hear about that business side of stuff too, but also the opportunity that the technology gives the industry. Yeah. And then we even got a little bit into the students. So I think that's really not students, but someone who might want to be a student.
Check us out, thrustinstitute.com. We have a bunch of blog posts about all these sort of different things as well. Yeah. And our social media, we're on.
Follow them on Instagram. It's worth it.
Instagram, TikTok as well. Thanks for tuning in on Nuts About Thrusts. Give us a like and a subscribe, and we'll see you on the next video.
All right.